And thank you for coming. I realize it's the last week and everybody's under a lot of pressure. And hello to all of you who are streaming and can't come here, but you're watching. And a future hello for those of you that will see this in the future. Today we're presenting Eric Paulos, who is our candidate for a joint position between computer science and design media arts. And we were actually very pleased to have Eric apply, because this is actually a pretty tall order to fill. You have to address a lot of issues in design and media arts and be aware of that whole field and hopefully collaborate with media artists, and at the same time you have to have a PhD and actively participate in academic journals and writing and etc. Eric received his PhD at UC Berkeley in electrical engineering and computer science. His research, scientific and social interests revolve around robotics and internet-based tele-embodiment, particularly the physical, oral, visual, and gestural interactions between humans and machines. He has developed several internet-based tele-operated robots, including mechanical gaze in 1995, personal roving presence devices such as space browsing, helium-filled tele-operated blimps, which are actually quite wonderful, and ground-based devices. Eric is a founding member of IEEE Technical Committee for Internet Telepresence and respected as an important contributor to the field of computer-supported collaborative work, CSCW. Welcome, Eric Paulos.
Thank you. Okay. Thanks everyone for coming. Did I turn the microphone on? I assume I get a signal if I didn't. Okay. I appreciate all of you coming, because I know it's the last week of classes and people are pretty hectic, but I appreciate the time you can give me today, and hopefully I can talk to you about my sort of background and some of the projects I'll just talk about that I went through that involve. So this talk will be a little bit of sort of the computer science aspects that I'm interested in, and some social aspects, and hopefully some of the other projects I worked on. This was just a slide to sort of entertain you while you're waiting, but basically it does hint at some area of interest that is important to me, and that is, I won't read this, but essentially this couple meets online, and essentially they say, hey, why don't we just get married without meeting each other, and they end up sort of going, well, wait a second, that could just be some guy playing a prank, and I don't know, what if this guy's some loser, and well, they call it off, but it's too bad because they really would have been perfect together. But it ends up they meet in real life, like normal people, and they hit it off. The message to me is that essentially our online tools are lacking a lot of issues about intimacy and trust and persuasion and sort of a richness that we basically exhibit every day as humans. And my interest is looking at ways to facilitate better sort of connections between people. To give you a little bit better illustration of what I'm talking about, if my slide advances. Yeah. This is not meant to be a literal mapping, but this will be sort of a motivational space of where I think about things. This is primarily work I did at UC Berkeley with John Canny, and the idea was we obviously have a lot of different media that we're basically trading off with every day. We make phone calls, we make video conferencing sessions, we do all kinds of things. And there's also this idea of media richness or social presence that's important to convey so that you have you can actually perform real work. And again, not meant to be any kind of real graph, but the idea is there's sort of this notion of like beyond video conferencing, at some point you just go to face-to-face communication. The question I'm trying to raise is what kind of other tools and techniques can we develop and explore to look at things beyond video conferencing? What other metaphors, what are the other ways to think about humans interacting? There's certainly a lot of nonverbal communication in that area. I'll give you a little bit more motivation so that it sort of sets a little groundwork. There's been a lot of work in the idea of this notion of social presence dating back a long way. This is one of the pieces which essentially conveys this notion. They measured people need a presence to actually convey themselves. So if you're sitting at a meeting and someone's just on a voice call, they're just voice conferencing with you, that person doesn't have enough presence to say, persuade you or basically have a way of interacting with you in that room. They almost sort of disappear in the background. So there's definitely a notion that people need a presence to actually have this sort of intense relational communication between people. So that's one thing. Another important sort of piece of work, you'll notice a lot of this crosses not just in computer science, but a lot into sort of social issues. Daft and Langle looked at this idea of media richness, and this is something that the notion is essentially that people, they looked at a business environment where basically people were in a business setting, and they said, it seems that they evaluated that people are the most efficient when they can trade off between different types of communications media during the day. I mean, sometimes you need to be having a phone conversation, sometimes you need to have a face-to-face, sometimes you need to have just an email. So they sort of looked at all these have different channels and feedbacks and different types of sort of immediacy and different types of latency issues, which is how quickly people are expected to respond. There's social issues with the way that people use this in their daily lives. And basically, they needed the organizations that were able to sort of choose among the richest set of these were the ones that were sort of the most successful. And in some sense, it wasn't that you just needed a lot of face-to-face time. There's certainly things such as where are the latest sales figures, an email suffices for that. Whereas I want to talk to you about, my salary negotiation, you need some richer medium. So it's clear that we need our new sort of computer-mediated tools to basically be looking at and exploring the space of further ways to interact. And essentially, right, you need these richer media to reduce uncertainty. You all see this, people say something and they put a little laugh out loud or some kind of smiley face to let you know, oh, okay, I see the context, that was sort of a joke. And that cue works, but that's not it'd be nice to find metaphors and cues that are more natural for people, the way that we relate face to face. Finally, our friend Marshall McLuhan kind of sums it up that really choosing the right medium is very critical. I mean, someone that sort of fires you through an email certainly conveys a different message than if they're doing it face to face. So the person, it's not just the message they're trying to tell you, but we really need to provide the tools to let them facilitate the way they want to present their message. And also, there's obviously all these technical limitations about how far and how rich these different interactions can be. So these are kind of a mix of different things that got me thinking about ways to look at this, this problem. I'll give you just one other example that's a little bit more sort of graphical. And this is an experiment done by Elena Rocco. She was at the University of Michigan doing work on looking at essentially kind of trust online. What this is a typical prisoner's dilemma kind of game where you can either defect or you can sort of choose to cooperate. And these people basically did several rounds of this betting game. It's unimportant what the details were. And this strong long line represents where they got together face to face and said, hey, this is how we play the game. This is how we should do it the best way. And they sort of coalesced and they got to an agreement. And then they sort of met again and they actually got to this, that was the naive optimum, and then they got to this real optimum. So essentially this says that people were able to believe each other when they met face to face. Same experiment, but this time meeting in sort of more of an email environment. And you can clearly see people were not able to sort of converge. There was this complete distrust of what people were doing. This is another indicator that there's definitely something in the tools that people aren't able to make the same kind of connections they do in real life. So So one of the things that I was looking at very early on, just basically the goal was kind of seems to be you want some real-time interactivity because that seems like a natural thing that's close to face-to-face, a high social presence and this media richness. I'm not trying to replace face-to-face. It's not really possible. That's not the point. The point is to sort of get that gap in between and fill that in. So an early project that I worked on, there's obviously a lot of other work in this area from a number of different people. I won't go into a lot of detail, but you can see visually that a lot of it represents little physical manifestations of people. This is a project to deal with people naturally glance around the room. This is a way to glance around your office and get a sense of, like, how can you capture the notion of glancing? They worked into metaphors. Up on the corner was a door where the metaphor of the door open or close conveyed whether or not people could sort of look in your office. So we're looking at those kind of themes, and gesturing is a big part of that. And there's also very much a tangible quality, or a lot of haptics involved. There's ideas of, can you do handshaking? Can you have kind of ways to sort of, these are little rollers that you can kind of communicate back and forth. A lot of them are very playful, and the point is to kind of come across and discover those things that work well by really just thinking a lot wider open about some of these problems. These are other projects that are more, NASA wants to make a little probe that essentially people would control and it kind of help you in outer space. they luck out because weight is not an issue. They just throw everything on there and it just works. Okay, so one of the projects I worked on early on was this project that Victoria mentioned. It was called Space Browsers. It was obviously sort of a pun on at the ID. Remember, it was web browsing. I was interested in browsing physical space. There was small helium-filled blimps of human proportions or smaller. They had onboard wireless electronics, little cameras, microphones, and speakers. You hook this up through a Java applet through a browser. So the idea is you would sit at your desktop or laptop computer and you could fly this around. And you have this sensation of having another sort of body. It was important that it seemed you needed some kind of body because rather than just having a camera in the room, camera on top of a screen, it seemed that I was interested in exploring what happens when you have a presence that I can actually approach someone and I can actually choose to disengage and go someplace else. And it was fun playing with blimps, too. There's a lot of, the Media Lab had done some autonomous blimps before. I did maybe 7, I don't even know how many of these. Some of them would pop and some of them would fly forever. There's Mylar versions. Here's some flying around. You could do these superhuman abilities by sort of sailing around and going off of ledges. I'll show you a video in a moment. But this is a little bit more of a sort of, oh yes, for those of you who recognize Stellark's in there. Not for any reason, just because he happened to be in one of the better photos that has the...
I'd say, I can say more, this is in Links, the design center.
Yes. Wow, no one ever picks that off. All right, I'm in the right place. People got the... It looks like these are sort of like its little siblings, and this was just somehow they were doing some random balloon thing. The idea was really to have a person have this independent presence, as I said. And this worked really well. It was very playful, but it had a lot of problems. I mean, essentially, people became less interested in just browsing a space, and they really wanted to communicate with people. So I was compelled to think about how well this worked for that application. And it actually, in some things it was great because it was a robot, but it was a friendly robot. I mean, people didn't say, there's a robot coming? Where? I'm going to hide. I mean, people were naturally excited about it. They would sort of go, kids would whack it, and all kinds of things would happen. But it didn't, some really important social cues, it didn't work well. It was sort of high maintenance. It only operated for maybe an hour or so. The battery life was pretty constrained. And it also had, the most advanced electronics it had on board where it had a sonar so it could kind of maintain height. It had some servo loops for controlling direction with some electronic compasses and things. But ultimately, you could never really detect things like side slip. So you'd come up to engage someone in conversation, and then it would start to slowly drift away, and the person would be looking around. And it really, suddenly the experience was really asymmetrical, and the person was really awkward. And finally, it looked very much like some kind of strange surveillance drone coming to watch you until a voice emanated from it, and maybe you recognize the person, which has a lot of implications, but at least as a social tool, it really wasn't working as well as I wanted it to. So the idea was to look at something that was maybe a little more not constrained with weight and such. And so, actually, there's obviously another big precedence in this in the art world. I mean, obviously, many of you have probably seen these silver clouds that Andy Warhol did, and Merce Cunningham even played with performances with them. So people have this really fanciful, sort of playful atmosphere around these objects. It actually ends up that my interests are certainly in this world of exploring social presence, but I also have an interest in looking at these crosses of projects that are kind of science and art at the same time. I mean, things like Leonardo da Vinci doing these drawings that were very much artistic, but they kind of depict scientific properties or principles or applications or tools. Or von Kempelen, who did these chess-playing machines that were actually fake, and there was a person inside of there controlling them. And it was this sort of deception, and it brought up, at the time, this big discussion about could a machine actually think? This was like a really big, hot topic, which actually we find ourselves still wrestling with today. I also draw a lot from the futurists. I mean, essentially this notion of really sort of extreme motion and machines. The idea that I look for building tools from sort of the artifacts that are in the technology of the time. And for the futurists, a lot of that was sort of industrial applications and sort of sound and lots of things along those lines. In fact, it's, yeah, okay, I won't say too much more about that, but I do find them, the way that they sort of address topics and themes and explore that area. Certainly just motion in general, but motion often the way that it's sort of abstractly perceived, and there's been an infinite list of people that have explored this. I don't see myself exactly in the sphere, but I draw on lots of principles of the way people essentially have built and constructed machines that have some kinetic sculpture or motion. More typically, there's this sort of very well-known piece, Jean Tinguely's Homage to New York, where it's sort of this large construction of devices and systems and mechanical beasts. There's even a blimp in there, or a balloon at least, that sort of cataclysmically destroys itself. And in some sense, the interest for me is these projects that really have a cross between drawing in the science community and drawing in the art community. Like the Homage to New York, Billy Kluver was involved with that. Billy Kluver also worked a lot with Robert Rauschenberg. Billy Kluver received his PhD from Berkeley, and he went out to New York and worked at Bell Labs. And at the time, he sort of just started hanging around the arts community in New York, bumped into Rauschenberg and other characters, and they started this group, a lot of them out there, called the EAT, the Experiments in Art and Technology. Pretty well known, but the idea is that this was a forum to really bring scientists together with sort of designers and engineers to really sort of start to address and think about problems in that space. It was one of the sort of few successes of really drawing these people together, and this is pretty inspirational. I mean, this is sort of, if you think about the time frame, 1965, it's sort of artists thinking, what is this thing, the laser? What is going on with this? We're hearing about this thing, and here's scientists are able to come in and say, here's what it is, here's how it works, we'll show you a demonstration, here's what we're going to use it for. There's some sort of science things we're working on, some theoretical limits and some other things, and the artists were saying, hey, I'm thinking about these other things, and it really sort of broadened out the entire spectrum of things, and that was a nice intersection. I mean, the way I see it is essentially the artists are essentially commenting on society in one way or another in most of their forms, sometimes more abstractly, but ultimately it helps to have them have an understanding of some of the science and some of the principles behind that. And similarly, the scientists, I mean, my sort of formal training is definitely in that background, and as an engineer, I'm sort of trained to very efficiently come up with really good solutions to things, but I think that there's also benefit from working with designers and artists because they're very good at, I think, really kind of like deep, like broad exploration of a particular research space. They're really good at sort of thinking about lots of different possibilities and hopefully converging on something, but a little bit opens up the discussion a little bit. Okay, turning back, it's a little segue. So this was the next project that I worked on. It was called Props for Personal Roving Presence. So I was intentionally trying to get away from the idea of calling it a robot. I mean, robot had this connotation of, okay, it's going to have these mechanical things and it's going to be R2-D2 or something. So this is essentially what it looked like. It was based on a really simple drive base. Now the differences here from the blimp or the space browser were now I could have facial expressions. There's a video on there of the person at the remote end. There's also a camera for doing it had a 2 degree of freedom camera at the top with zooming, so you could actually direct your gaze a little bit to see what was going on. And it had a little pointer for actually gesturing and pointing, gaining attention, those sorts of things. And obviously the same sort of speaker and microphone. It also benefited from the fact that by this time 802.11 was kind of there. The blimp was a wireless nightmare that no one ever wants to hear about. You just don't want to hear about it. And now it had some nice properties. You could actually come up to someone, you could stop and converse with them. I wanted to make the video a lot better so you could actually come up and you could collaborate with someone over a table. So it was very important that you could read computer screens and text. You could turn the camera down and look at a desk. You could work with someone with the laser pointer. You could be pointing at things. Right. Okay. So these are obviously canned photos that I just took to give some kind of flavor of what's going on. I didn't actually work on aircraft with this, but it looks like, I don't know. So I love going out of campus and taking pictures at strange places. People love doing this. So obviously there's a lot of practical applications of just, okay, this is kind of, you could do this idea of management by walking around. I mean, a lot of times people go places to be present, to have some kind of, they want to walk on the factory floor. What's going on? What are the troubles people are having? What's really happening in this lab? What's happening on this production line or facility? And this was essentially, there's a lot of those tasks that you wouldn't have to be there face to face, that you could actually perform some of these, maybe if you have monetary or time constraints, you could actually go and have some kind of other presence that would be able to facilitate some of the same interactions. the idea was that rather than if these two people had a video conference, they might say, okay, at 3:30 we're going to go and have this video conference. Then they're kind of in this room. And secondly, it's also it's like temporally and more spatially constrained. Whereas this person, I mean, granted, this is like a little bit of a push. I'm not trying to say that this is like the perfect solution, but hopefully this person is interacting in a way that's pretty comfortable to them. They're saying, look, there's a problem over here, and I don't understand, and back here there's something else. And basically, the other person can sort of navigate around and interact in a somewhat similar way.
The machine itself is to 100% remote control. It's not, or it has some little individual brain inside.
Right, so that's a good point. It does have some amount of local, I guess you'd call sort of automation. Ultimately, it is controlled by the remote person, but there's things such as some basic navigation. There's a lot that you could benefit from just having some autonomy on it. So it had things such as, well, I'd like to go over there to where the sprite is, but I don't really want to sort of navigate it the whole way. So there was kind of point and click things. I'd say, I just want to get over there, and then I could kind of look around and sort of. So that's actually part of the design challenge. It was like, where's that proper line? And I actually would have liked to explore more of that, but you're asking the right question. It was also, it's designed to look sort of flimsy. It probably looks as if it's really like just a simple little device. There's an intentional reason for that is I didn't want it to, first of all, I wanted to try to have it be friendly, so I didn't want to have it too sort of uber metal kind of looking device. And I wanted it to look kind of small, like it wouldn't be overly intimidating as it came up to you. These are kind of playing into social issues. And finally, it was sort of a trade-off. If I made too much of a body shape out of it, then you start to assume gender and age and identity and you get into a lot of other issues. So I was trying to have kind of, I don't know, like sort of abstract cubist version of there's kind of a hand thing here and you get it, but I didn't literally spell it out. That's hopefully the idea. This picture you mean? Or
No.
The project. Yeah, well it was almost all of this work was done with John Canny, who was my advisor. I mean, it's always your advisor's involved someplace in there, right? So he was pretty inspirational in helping to, flesh out some of the things. Right. So all the projects, I constructed them and designed them, and there's, all kinds of microcontrollers and software and networking protocol stuff.
But the footage from the shop, or is already made product?
This here. So this is basically version 5. I'm not really showing you pictures of the early ones because they're pretty crufty, but the earlier ones were, like version 1 was take a remote control car and chop it up and do it. Then version 2 was sort of, all right, buy my own wheels and motors and all that kind of stuff. And then version 3 was, let's just buy this base for like $2,000, and then there it is. Mainly to save time. Learning experience for me to not like spend all this time doing these things, but yeah, so that is a commercial base. Although this company's now out of business, actually. I tried to get one more extra one, and the guy's like, we're sold, of all things, the robot company was sold to 3Com. Okay, so, okay. So yeah, this is more of the same kind of weird interaction. Sorry that I'm in all the pictures, but it seems to be when it's working or something's happening, I'm nearby, so.
But you look silly enough that it's okay.
I'm glad you agree, because
It's nice.
so so there's sort of two sides. One was I wanted people to be able to drop by the lab or basically go to these facilities, but I also wanted to look at really outside that space social interactions. So we even put this down onto Telegraph Avenue in Berkeley. I don't know if you're familiar. For those of you that don't know, it's kind of a Haight-Ashbury sort of scene. But so as soon as I put this down, a lot of people fled, and I kind of cornered them. They said, well, they said, that's some kind of police thing, and I'm wanted by the law, and I don't want to be around for this. But, that said something that it was sort of designed. It looked too much like basically some kind of weird surveillance drone. Right, and I do understand that. People certainly did play along. A lot of people obviously didn't all flee, but several people just said, whoa, what is that? And this is a social issue with privacy and cameras that you get all the time. And that's... It's an eeriness. So this was just people interacting with it. These weren't canned, this is just people actually interacting. And I was actually really controlling it from some other location, getting its tarot cards read. doing some other things. This is, you can tell this is an earlier version. The bass is different. There's different kinematics on the bass and stuff. Okay, let me show you a little video of that because this project's much more of a visual thing. All right, a hit mode, right? That's right. Okay, it should be there. Okay, so this will just give you some idea of sort of how it moves. So the idea is that this is the blimp. It's for some reason not in color, but it really is. I don't know.
Can I ask you how you navigate with such a blimp up and down? How does that
Right. Well, yeah. Oh, I should. Yeah. I'll show you what the interface looked like when at the end of the video. But that's a good point. So this was just flying around.
This is from the point of view of the camera.
Well, you do see. I think you see something from. There's the point of view from the blimp. Now you'll see this is 1995. The video quality, like frame rate, is really low. Wireless. There was nowhere near 11 megabits per second. But you see, going upstairs and a lot of your typical robotics problems, it worked really nicely. Went outside, it blew away. So that was no good. This was at SIGGRAPH, basically.
How does the up and down work?
Oh, the up and down. Sorry. Okay, so I'll tell you. You hit. At the time, I was trying to interface to common, like how you see people. You'll see people basically. I don't know if they're fleeing or they're just sort of getting. You have to realize there's a voice coming out of this too that you can hear, but it's not. There's no audio on this particular tape. And you'll get people like this woman. You know, not sure if she's sort of running from it or sort of playing with it. Oh yeah, sorry. So you have to imagine there's little propellers on it, so you'd hear like a.
Yeah, it's really interesting the way it actually has a presence, even though it's a very simple shape.
Well, the idea is you would hear it coming a little bit.
Right.
It's maybe a little far-fetched, but it couldn't totally sneak up on you. You hear this kind of.
Yeah, so it gives you the sense of something.
Right.
Or someone.
But to answer your question, the up and down. So one idea was. Telepresence is not novel. It's basically been around for a long time. What was novel about the project was that, typically telepresence was expensive hardware, very custom, lots of training required. Application was go diffuse thing X or go explore dangerous place Y. This was something easily accessible, something that the application, or there's no training involved, and the application was sort of kind of socially hanging out. How could you provide interaction? So with that in mind, the goal was not designing custom interfaces to it. We're trying to say, so if you called me up and said, hey, can I use this? I wouldn't say, well, let me ship you out this strange USB thing I built. And it would be, do you have a keyboard and a mouse, maybe a joystick, that kind of interaction. So the height you would control through, I think it was at one point just A and Z, and you would set it to a constant height, and then you would cruise along. It would maintain locally with the sonar the right height.
But are you putting gas out? Or
Oh, right, with the propeller.
It's with the propeller.
Yeah, so it's like, I don't know, there was all types, there's like a whole way, it was many different arrangements, but the one that basically worked the best was you would have a propeller on the front for steering, so it would blow one way or the other. You would have a propeller underneath for thrust, for forward, and you'd have one on the back for lift.
What is pointing?
Pointing up, so right, so it was sitting here, it was sort of, you could drive it up and down, one here for that direction, and one on the front, for steering. Yeah, you would think you'd want the propeller on the bottom, but there's an airflow issue. You can't do that, and lots of other stuff. So you do get strange torquing sometimes, but this is just a little bit of the. Oh, I don't really. Okay, I don't really need the audio, but I don't know. Is there a? That's all right. This is just redundant of what I already said, but you can just watch this is essentially what it looked like when it moved around. This gives you another advantage of what the video had improved by this point. So you had a much more sort of continuous presence of what was going on. It's actually in color. I'm not sure why it's not projecting color, but you imagine it's oh, I know why. This is an SVHS tape, and it's probably playing. Okay. It did fall over a couple times. That was mainly when the. Reading and making simple gestures. Okay. It was mainly. it would fall over when I was debugging it and I had the sonar off. It had sonar, and you could actually run into something and drive it until it fell over. It was very hard to fall over in the sense that it was, all the weight was at the bottom. Actually, the audio on this is pretty interesting. This is an actual sort of more of an interaction. I'll just crank this up. Great, what are you working on here?
Well, actually, I was hoping you'd come by. I'm trying to teach you through this. You want to help?
Sure, let me see.
Okay.
Yeah, that's it. Go ahead and put it on the side next to the hole.
Uh-huh. Okay.
Looks great. Yeah, just make sure this goes up far enough. Now, where are you going to put the hole exactly here?
See where I have the marks? How does that look?
Okay, so this is admittedly a very contrived kind of example, but it was trying to get an idea of how essentially two people would work together and sort of be co-located in the same place, and how one person would be able to see what's going on. And there was a better video. I couldn't find it before I came here, but it was actually, I left this with some engineers in the civil engineering department that essentially used this to place sensors on, I'm not sure what, oh, this was, sometimes I actually gave lectures with this, so rather than being actually at the lecture, I would use this to show up. So this was where rather than, this is slightly modified. I mean, rather than having the pointer, I had this sort of, it was a military assault light that could sort of shine on people to pick them off and kind of just highlight people in the audience and sort of interact with them. And I could put their video on the screen and overlay video of them with other people. There's no, I don't think there's any audio on this, but you get some idea of, and also the face was more, I was changing it so that, this is done in collaboration with Artmark actually, that they were doing the faces to sort of overlay, if you wanted to be happy or sad, you could basically choose to represent your form in a different way than you actually were. I think that's, so and people had, the interesting thing is people had strange perceptions of this because of the way that they, I gave a talk at Stanford, and then about halfway through I actually came back into the room and interacted as a real person. People said, oh, I thought you were taller or shorter, or they had all these preconceived notions about what I was, how I was.
What about the distance for the transmission? How far can this robot go without making it a very complicated thing?
Right. Well, this last one basically went on the belief of if there's 802.11, it just will find that and work. So then all the roaming things worked. In our building, it was not a problem. Most of the Berkeley campus had connectivity.
How many feet are we talking?
Oh, so that's, for every base station, it's a maximum of like 300 feet, but that's line of sight. It's more like 120, 150 feet with all the occlusion.
Would it be technology? I mean, it probably costs a lot of money, but it would be possible to give that thing a really wide range, right?
Yeah, in fact, well, the real thing was eventually, if you just extract this out, it's very simple that this will be able to run on the 3G wireless technology, and then essentially you could just drop it on any street, any place, and it's connected through the regular cell phone network. There's the bandwidth measurements that I did are definitely within the limits that you could use this. So in some sense it was, let's try it in the laboratory, look at the problems and challenges about it, and then try to look at exactly how, because people will eventually be having video interactions, but I think there needs to be more of a tangible physical presence. Maybe this isn't the exact solution, but at least have discussion about it. Okay, try to move along. I'll just kind of go through this really quickly. There were lots of different interfaces of this. One was using sort of like a window that you would actually have sort of a panel PC that you could move around and have interaction with a camera. And I already mentioned this joystick. The joystick was easier. The blimp was really hard. The joystick with the prop was easier. We just obviously move it forward, backwards. That was pretty common. And you could also do head control with the point of view control that you normally would have, and gesturing and zooming as well. There was some zooming in the video you probably saw with looking at the boards. This is a little bit of sort of just the basic architecture of how it's put together. Sorry about the bad little icons at the top. But basically, people sit at some level. There was a bunch of application code written in so many different ways. I mean, at first it was C++, and then it was Java, and then it was so many different things. But basically that glued into this suite of protocols, all these googly numbers, H.263 and all these things. Some of them you might recognize from the audio codecs as well. This is essentially a suite of protocols that all gets lumped under H.323, which is basically a well-adapted sort of set of ways to provide interactive support for multimedia across networks that don't have quality of service guarantees like the internet. So it adapts, it has all kinds of rate adaptation, and people always often say, why don't you just use like real video or something? It's like, that's not the right solution because that's buffering and you need interactive support. And then obviously that would talk to all these hardware that had all kinds of little microcontrollers and things at the bottom. I'm not going to go through all these, but this gives you some flavor. We started to think about what kind of communication channels is this supporting and what kind of communication channels is this addressing. Some of them are very obvious. You wanted two-way audio or two-way video. Some were not. I mean, mobility, having independence. It was kind of trying to capture, you all came to this lecture and you're going to have some interactions, but maybe the interesting thing is also when you leave, you run into your friend on campus as you're cutting across. That was an unplanned, spontaneous interaction that you wouldn't have had if you just dropped in like the people that are maybe watching through the video conference. So there's some reason for coming and being present. There's some reason to pick up on these spontaneous other interactions. One of them that's not so obvious is this idea of proxemics, which is this idea of social separation between people's bodies. So this is very cultural too, but in general, people that are, there's defined spaces. When you're in someone's intimate space, you're basically going to be intimate with them or you're going to fight with them, as you can see. And this is a pretty clear thing. I mean, if someone does get in your space, you feel very threatened. The reason why it was important, there's these weird natural spacing that people do all the time in settings. And it was important that this device played into those same spatial separations, because if I wanted to talk with you and I came this close, it's not the right interaction. I should be at this distance from you. So can it maintain those sensory shifts was the idea behind that. Directed gaze, I won't go into a big detail, but just it proved really valuable that you could actually direct your gaze and it was really engaging and you could look and kind of navigate in tight spots. And physical appearance, again, this ended up being a real big challenge because even just something as simple as choosing the height, the first versions I made were pretty much my height, and people that were shorter than me felt very intimidated by something looking down on them, a mechanical thing. So I made it a lot shorter, and then people treated it like a dog or a child, and that was not right either. So there's some kind of, this really needs people with a really diverse background to look at some of these issues. And gesturing. The key thing about gesturing really was that we were interested in using continuous input devices. So rather than saying, hit the H key and it'll say hi, or ask a question, it was more, because there's obviously different ways. You can ask a question like this, or you can ask a question like this. So it was really looking at how you can create a much richer way of interacting. We did do some usability studies on this. We placed this this is a library setting off campus to look at how people would actually use this. Kind of because often these things it's very fun to play with, but I was interested in doing real evaluation and looking at usability studies. So this was just a group of people that had really no experience with video conferencing at all were using this system. And the good news, again, I won't go through all the details. Basically, the good news is they all completed these tasks. I had them essentially, could you go up and read these things on this table? Could you navigate in this room? Could you move around and get behind things and interact with people? Everyone was able to do that. The biggest problem people had was really this delay and synchronization between the audio and video, which is common with video conferencing in general. This is a separate problem. And people felt like, when I asked them, would you think you'd ever use this? Most of them were, yeah, but people expected me that way. People wouldn't want to just show up with this unannounced. We also looked at some network effects. We had people as far away as Europe use this, so some very strong latencies. You can mask some of that by actually the way that it moves. But people were actually able to, they were able to actually move around without colliding with anything. I actually thought this was going to be a failed experiment and said, well, let's just see what kind of mayhem happens. But people were actually able to use this and interact with people. People felt like they actually were at Berkeley and they went outside and they could, because this, with the networking, you could go outside and do things. Biggest problem, huge delays. Benefit, and this is sort of the somewhat selling point, is it's basically controlled by another person, so the person kind of adapted to that. I didn't tell them it's going to be strange delays, but people would, sort of see someone walking, they'd say, hey, how's it going? But with the delays, that person had already passed them by that time. So the person just figured out as soon as they see someone at a distance, they would say, hey, 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 and then it would sort of work. Not the right solution, but at least the idea was there's going to be strange interactions and people can kind of adapt. Okay. Uh-oh, what happened? So all these tools that I've been making essentially were dealing with people's presence online and this idea of remoteness. And a lot of people actually sent me mail and thought these were fake. They thought this was not real, that there was just some kind of trickery going on. This is obviously an early webcam where this guy basically showed up one day like this and people were really worried that something had happened to him. And of course he was faking, but it brought up this issue of kind of authenticity and basically issues about, kind of epistemological issues about distance and people's presence. So this motivated some work that myself and Judith at the Media Lab and Ken Goldberg and I worked on. There's a project called Legal Tender, which basically allowed people to come in and gain access to a small portion of a pair of purported US $100 bills. This is right when the new $100 bills were issued. And you could come in and actually perform experiments, so you could actually burn a hole in the bill or puncture the bill. But before you actually did that, you gave up some of your anonymity. We found out who you were, your email, some other stuff. And before you were actually able to do that, you actually were told this is a felony to actually do this. So you were sort of committing a criminal activity remotely. So often people just click around on the web and have fun. It was, wait a second, so this next action is going to actually make a huge difference. Along the same theme, I was working with Mark Pauline at Survival Research Labs. I'll say something about in a minute, but basically we were looking at this idea of anonymity and controlling sort of more lethal devices. Obviously, I'm very interested in the social aspects of how people interact, but you could see a lot of people, one of the things people often say when they're using the device is, where's the fire button? Because the perspective is very doom-like and things like that. So this was an idea to look at augmenting another tool that would let people actually have some kind of a lethal telepresence and see how that would play out. There's some little video, like 30 seconds of that. Okay, this was just a device that was already set up as sort of a telepresence tool. You can see it's head-mounted display with 2 cameras on it. It's a cannon that fires a shot of compressed air that propels a projectile. It's about a Coke can filled with cement. And the idea was that... Okay, that was the only loud part. So there was a Java interface that we designed for this to let people actually have a video view of what was happening. And the idea behind this project was to look at how people would essentially interact if they were anonymous and had control of something that was a more sort of lethal device. And it would sequence through, it was very hands-off, it would sequence through a loading cycle, and it actually had a magazine on it, so it wasn't something that needed a lot of user input. And this was run a couple times when they opened the ZCam and also from the ICC in Japan. So it wasn't something that was online every day or something like that. Okay. One of these 2 things. That was just a picture of the interface. Okay. The projects I told you about so far are more of a sort of one-to-one mapping. In other words, one person controlling one system. This project caught my eye. It wasn't done by myself. It's called the Cinematrix, and it was essentially a way, this was at SIGGRAPH a number of years ago, it was a way for someone using these little paddles to kind of vote and say, oh, we want to choose your own adventure or kick the speaker off or do some kind of behavior. And then one of the things was actually moving a little thing through a maze, like a little maze. And I thought, this would never work. People would just go crazy. It would just completely fall apart. People actually did come to some consensus. So the belief was that you could actually drive the system with a group of people to do some kind of act. So I thought, maybe an interface to this, just like we were looking at the props and the things before, would be some kind of little more elaborate system where you could actually, a lot of people, as you can see online, looking at some situation and sort of voting for what they want to do. Like, let's walk and follow those people. Let's go buy a t-shirt. Let's different actions. So the problem was, what kind of robot is going to actually do this? And who's going to make these decisions about what's going to happen? So this is still kind of an open challenge, and this is still being worked on by a lot of people. Ken and people at the Media Lab and a number of other places. And the idea is you'd probably want to use some kind of a system that has a head mount. This is the ultimate robot, so to speak. This is the sort of a person that actually can control the actions. Now, this is partially, there's two things going on. One is, it certainly has all these issues of sort of master-slave and issues of control and issues of empowerment and sort of these odd interactions of, is this person not really interacting with this person? It's sort of a remote person, but it's this person's presence and whose gaze gets the attention. But they're actually, okay, there's actually practical applications. This was another version of it that essentially had a steerable laser pointer so you could point at things. But there's also real applications for this in essentially education and entertainment, sort of reality shows, driving reality with lots of people. And if you want groups of people to go and visit places like a microfabrication lab, for example, we use this, and you can't really let a bunch of school children in there, but you could have an interactive person sort of being guided through. So there's some exploration into this. Okay, I'm just this is just briefly, for reference sake, a lot of the work I did early on was with Survival Research Laboratories. For those of you who don't know, it's a group that Mark Pauline and a bunch of other cohorts started in the late 70s, essentially doing thematic shows that involved scripted interactions between a lot of very large-scale machines, a very sort of visceral experience to be at. They essentially involved a lot of sound and a lot of smell and sort of a very, very large-scale productions. They were actually scripted. They kind of involved this manifesto of kind of releasing the most energy in the shortest amount of time. So the key thing is this allowed me to actually gain a lot of skills about how to put on these larger scale productions and how to basically orchestrate very complicated machines. And furthermore, there really was the connection to a lot of different people in this organization, because there's a lot of different skill sets that people have that I was able to make connections to and really learned a lot. And I don't know, how much time do I have left? Like 5 minutes or something? Okay, I don't know. Try to.
We're going to have a performance in 3 weeks here.
Yeah, so actually there's always, you could probably ask me any day of the week, there's some performance in progress, but yeah, the latest was there's going to be a performance here in LA. Yeah, what, July or something, yeah. So stay tuned. Right, he had a show scheduled for here, but after 9/11, people basically didn't want to have a performance. I'll just show you a minute of video for people that... Okay, I'm not going to go on and on with that, but basically just a couple points. I obviously that's not something that I did, is build all these machines, but I was involved in a lot of this sort of inner electronics and some of the control for the mechanisms and robots, and some of the design decisions on interactions between these things. Secondly, it's not about sort of robot wars, who gets destroyed. It's actually scripted interactions that they're designed to drive the machines towards some level of entropy where basically unexpected interactions occur, but it's not designed to be everybody destroy everybody and go home. All the machines pretty much live on. Okay, I'll just finish with a couple pieces that I did recently, and I'm just saying tactical media, but basically when I operate outside of Berkeley, I often use this group, the Experimental Interaction Unit, which is basically about the designs and looking at the way people interact experimentally with technology. So 2 projects I'll mention. One of them was this project called the I-bomb back in 1998. This is the information bomb. And I'll just play a little video which will explain it better than I probably can. After I fast forward through. I know I got to click it up there. Okay. The efficient execution of an information war campaign against a modern industrial opponent will require the use of specialized tools designed to destroy information systems. Electromagnetic information bombs, or I-bombs, built for this purpose can provide a very efficient tool for conducting an information warfare campaign. The I-bomb creates an extremely powerful electromagnetic pulse which disrupts and disables electronic devices and systems within a limited range and without physical contact. A specially designed coil directs all the stored energy directly into a magnetic field. Trusted operators using a key interlock system can control and monitor the charging of the high voltage discharge capacitor. So essentially it's the I-bomb will also corrupt and or erase any magnetic storage medium, such as floppy disks and credit cards. The result is the creation of a physical space guaranteed to be devoid of technology, a technology-free zone. So basically the idea was to intentionally create electromagnetic pulse to sort of have a place that wasn't harmful to people, but had some kind of actually pushing back of any kind of technology. Kind of more for people to have to acknowledge their sort of credit cards, their PDAs, their cell phones. And it was also sort of designed with the thought in mind, a lot of people were saying at the time, the people with the most information have the most power, and I was more interested in looking at, well, what if you could actually disrupt that? And also that it was a real tool, actually. Okay, so the final thing I'll show you. This also wasn't a Luddite machine. A lot of people think it's some kind of Luddite thing that I just hate technology and I want to destroy it all. It wasn't designed to do that. The last thing is I became interested in one of these 2 screens. I became interested in the sort of very real aspect, which we all know too much today, of how easy it was for people to actually get access to lethal pathogens. You could actually, in 1998, order anthrax through the American Type Culture's website and get it delivered to your home. So I worked on thinking about that kind of issue and making it very real and having people have a real confrontation with that. And I decided to build a vending machine that would actually lead people through an interaction of purchasing and kind of designing their own pathogen. And I'll just show you a little minute of video, and then that will be all. Appreciate you. Okay. Yeah. Okay. Public acquisition through specialized lethal biological pathogen vending machines. Although these machines will share many traits with today's typical vending devices, there will be new demands placed on them by governments and society. These systems will be required to automatically and safely cultivate, monitor, contain, package, and properly dispense lethal biological pathogens. Furthermore, the vending device must accurately record, track, and monitor the individuals using the system and observe social trends and viral demands to make long-term predictions about humanity. The device is called Dispersion. It is the first in a series of next-generation public vending machines. Sealed behind a biosafe shield is a Microzone 4 rated automatic robotic laboratory where pathogen storage, breeding, nourishing, and assembly is contained. A customer initiates a transaction with Dispersion using a fingerprint recognition hardware system. Rather than have the user directly purchase biological material by name, the system has been designed to be usable even by the non-biological scientist. This is done by asking the customer a series of questions concerning the various properties and qualities that they desire in their lethal pathogen. Here we see the dispersion radius, which is the expected airborne flight distance from the discharge epicenter. The next screen is the spore survival time. This denotes the average life expectancy of the active biological pathogen after its initial release. This can vary anywhere from a few seconds to 60 years and is based on actual facts about known pathogens. The next property is the infection rate. This is the mean time after initial contact for the biological pathogen to commence active infection of a host. This varies as well from a few seconds to several years. Dispersion requires a user's complete attention. At no time can a user move back to a previous screen to change their decision. The contagion degree is the probability of continued disease transmission via indirect contact with an infected host. This allows an individual to control the level of epidemic. All of the data is again taken from known incidents that have occurred associated with biological warfare research around the world, and each are documented accordingly. The pathogen is assembled within the biological laboratory housed within Dispersion. The final pathogen is then vended from an opening near the bottom and is safely contained within a sealed, unbreakable vial with a screw cap. All right. Gives you the basic idea of kind of what that was. Maybe we can have questions or something now. I mean, we sort of started late, so I'm kind of trying to juggle with the time. I don't know how tight we are. The only thing I would maybe mention is sort of the latest thing that I'm working on at the Intel Research Lab. Okay, so some of you, I'm not sure how many of you know, but I'm currently at this new research lab at Berkeley. Intel's basically interested in designing 3 new labs for doing research. One of them happens to be in Berkeley, and it's sort of I'm looking at ubiquitous computing and extreme networking using, actually I have a little demo item here.
The year-long deployment that you were talking about?
Yeah, this is basically, so one thing that we're working on is these, that you can fully handle this, they're completely destroyed, it's not like you're going to damage it. These are small little, what they call motes. They basically have onboard microcontroller, wireless connectivity, and a bunch of sensing like accelerometers and stuff. The idea is to basically look at this. We all know there's going to be technology everywhere. It's sort of looking at issues of, there's certainly design systems things of how do these locations, how do they define each other, but also how do you deal with ad hoc networking, which is these things are sometimes connected. How powerful in terms of just energy, or it's basically, that's a pretty small version. That would last like maybe like a week or something. So we have other ones that the goal is a year. Don't touch it at all. It just runs. So there's all kinds of obvious things of sensing the environment, watching habitats, watching spaces. Once you can do that, you can then start to infer context. My interest is sort of, it's 3-tiered. I'm interested in this idea of tangible media, which is this, how do you actually have physical interactions with systems? There's obviously a lot of work in that area. Anything from obvious things like manipulating bricks and things that have physical, tangible interactions to very abstract things like bottles that you can sort of move around and they sort of have implied interaction with them. These little buddy bugs that basically are instant messaging, but instead a bug will move around. So some of this is a very playful space to be in. Some of them are augmenting things familiar to us, like tape measures, and also even your PDA, so that if you're tilting it or you're moving it towards your face, it kind of can imply, oh, I should record something. Oh, this is what's happening. A lot of context. I like this idea of sociable media. So this is where a lot of the idea of sort of communication and context and culture, like how do we actually deal with people interacting. And there's obviously a lot of work in that area too. Some of them involve visualizing things that are very abstract to us on the online world. Things like crowds, faces, kind of how can you do this trust and persuasion? What are all the issues of nonverbal cueing, the glancing stuff? And finally, this idea of embodiment, which I pretty much captured earlier today, with just having a real presence and having this participation in real time in real physical places. And some of the work that I obviously did earlier ties into there, and some of this other stuff that was in some of the other slides. And so for me, I'm looking at essentially things that cross all three of these areas, so that it's social, it has a tangible quality. People are very well adapted with dealing with physical objects. We can pick up cups, glasses, keychains. All this stuff is very common to us. Things that kind of exist in this space now. Some really interesting projects, like a picture frame. You approach it. This is, you say your partner or your, that it knows that the other person knows you're looking at it. You can sort of touch it or rub it. It's kind of an ambient telepresence that's connecting the people together. Augmenting sort of cell phones and other things, so they have other types of haptic feedbacks. Even things common like a cup that basically you could tell if it's full, if someone's drinking it, just kind of giving some kind of ambient telepresence about what's going on. So that's kind of just a flavor of where I'm working in. I don't have sort of like 20 projects in the works, but that kind of gives you where I've been and where I kind of see things, especially with these little motes. There's a lot of information you can abstract from them. So, thanks. Yeah, sorry, I kind of went fast at the end, but I was trying to...
This whole notion about art, so if we think about props.
Right.
Do you see that as an... Okay, Eric, so, so your work is situated in this sort of like on the field, sort of like, which is partly sort of like, let's say, technological research.
Right.
Partly sort of like arts, whatever. So, for instance, if we think about props, how do you see it yourself? Is that an art project, or is it more like a sort of like research project, right, for potential applications or things like that?
Yeah, it's a good question. Sometimes it's good to make that distinction up front. I mean, I think for a lot of that, some of it's a blur, but basically that project in particular, I was really initially trying to explore a lot of social issues and really trying to engage the research community in, say, computer science and in sociology and other places about that. Now, when I took it and put it into, for example, I sort of modified it a couple times to do things that I was trying to do much more of a sort of artistic approach, or something that was much more, it wasn't a literal interpretation of here's two people coupled together. It was, I wanted to look at it as more of a creative piece. But the project in general was really trying to explore a science realm, and I think that generated enthusiasm and discussion in other communities, and that's kind of where I saw the impetus and the sort of coalescing of things happening. It's kind of a long-winded answer, but I think a lot of these it's hard to nail down. I don't see it as this is a 100% art piece. I don't see it as this is 100% just computer science. It's kind of, as all things, it's contextual, it's how I present it. Yeah, I don't know if that answers your question or not. Yes. I mean, a lot of the things are like that. You can tell. I mean, some of it was, go ahead.
You showed us this one picture from this performance, what has taken place at SIGGRAPH with the red-green thing, you know.
Right.
So from my experience, that was the very only well-working mass interaction I have seen so far. I mean, in this context of playing a game. I mean, I have never seen anything comparable yet, and it's a desirable thing to do these mass interactions, but it seems to be difficult to find something better, right? You showed this picture, but I didn't get the point why you were showing it, and that's not a real question. The question is, more, have you found any concept what could go beyond this really exciting experiment they did there a couple of years ago?
Okay, so you're talking about
the red
right,
green thing,
right? Cinematrix. Yeah. Oh yeah, I think that's going to be a really big deal, because I was trying to kind of allude to that was kind of collaborative telepresence in a sense, and suddenly you had this notion of you were the viewer, but you were viewing with others, and you were driving the entire system.
And it worked.
Yeah, and it worked. So imagine, I mean, the picture. I think the right picture is. I don't know where it was. Someplace in here. This one maybe. Where it was all these people online doing something. So if you just think for a moment, just our media today, dominated largely by television and other things, but that viewing platform is very common. People talk about interactive television. You can imagine these kinds of things where entire people are driving real physical experiences outside. There is true, the gaming thing is true, and it's good that you sort of, like, that we fess up and say there's a gaming element, because this is a community thing. And in fact, there's a lot you can leverage on with that, because people are sort of playing a game. I think this also crosses a lot over into some of those ethical issues, because it's sort of, oh, who's really in control here? You can start to sort of have those kinds of dilemmas. But I think this will be really big with the entertainment industry, really, because of there's a lot of more work to do, but essentially that people will want to have experiences with community and try to reality TV shows, right? If people like those and they want to be more involved. They had certain shows where you could actually vote on who would. I think there's online you could vote who you wanted off the show. I just read about a piece that there was a storefront display. We've all gone by these. It had real people in it. You could go online and tell the people how you wanted them to pose, and they would pose that next day. Vote depending on how people voted. So people want these sort of weird interactions of remote and also real reality, and it's unclear. There's a million questions with this. Should this be sort of first-person perspective? Should it be third-person perspective? Should this person have a voice? Who should be? There's all kinds of things going on here. I think this is probably a pretty big deal.
I think I understand the question. Just that you went through this slide really fast, and you maybe didn't explain how the teleactor worked and how that connected to the, what is it, Cinematrix, whatever it's called.
Oh, the Cinematrix.
Because, maybe if you could explain how this interface worked with people and their computers a little clearer.
Right.
In relation to where the teleactor would be standing or something.
Right, sorry. You're seeing the view from the teleactor's sort of head camera. And this is this is a mock-up, but the interface does actually exist. There's a real Java applet that I just don't have a screenshot of. These are all these obviously individual people, and you would be seeing this interface, and if I was, say, John, and I went over here and clicked, then my sort of icon kind of goes over here, and I can type in messages, and you actually gain sort of some kind of credibility in the community. Like if I just get on there and type in, shoot your head off, I get no credibility. I mean, you have to, realistic people will do very odd things in this environment, so you need to have some way of having some control, maybe not always, but, and then essentially there is a lot of research into how you you decide the voting, and then the system would move forward. Right now, it's a little bit, the thing I don't really like about it is it's very sort of event-driven. It's sort of, at this point, people vote, and then say we decide to go buy a t-shirt, so then we go to buy the t-shirt. But it's not, you're missing the continuous aspect of reality and video and all those things. So there's some issues about how to drive the voting so it can actually be more continuous. The user actually would hear the conversation, so they could choose to converse with someone. So someone could drive me up to someone and start to converse through me. Does that kind of answer it a little bit? Yeah, confusing, but. So that's why it says 5 seconds remaining in the vote, because there's like a time limit until it sort of expires.
Could you shift a little bit and talk about how you would approach teaching students that would be mixed between media arts, design, and computer science? Have you done it before, and how would you approach it?
Right. So at least At Berkeley, the sort of courses I was somewhat involved with are obviously very traditional. Some of them were computer graphics and things like that. I also ran some sort of other non-traditional classes, which turned into more reading groups that looked at the flavor. I mean, some of the, like for example, I wanted to have these meetings be not in the computer science department. I wanted them to be open to other people and feel like I want to draw people in from all other parts of the campus. Now, in sort of retrospect, I think the things that interest me, the sort of crossovers, I think that merger is getting much closer, especially when I start talking about sort of tangible media and social sort of media. I think computer scientists should be working on those kind of issues, and obviously those challenges are pretty broad, and it should be people that really have good design aspects and theories about art and bringing in sort of context about that. The things I'd be interested in, this is kind of like a high level bit, but things that interest me are along those lines. So basically issues of presence, issues of design of physical systems and the way you interact with them, sort of a lot of tactile kind of things, and also visualizations. A big thing is ambient displays. A clock is an ambient display, but you can think of a lot of other ones. Some of them are just playful things, the water fountain that changes, or the skirt that goes up and down with the stock market. But that playful element, I think, is an important part of actually getting people to open up discussion about it. I think computer scientists would benefit because that basically broadens a lot of the thinking about, they've been designing all these great systems for so long, and now it's sort of, look, ultimately people need to be interacting with these things, and we should start looking at not just traditional ways, but very novel ways that people are going to view them, touch them, interface with them. So classes where people actually build things, and I'd probably want to run classes much more like a studio than a traditional computer science class, where it's actually sort of more critiquing and more project-based, where you kind of build something, because yes, we all know, especially here, it's a little bit tighter, it's quarter systems, things don't always get done, and it's lots of little wires or whatever it is, but you learn something at the end of the day, and it's sort of a building tool for designing things later. So I don't know if that answers that at all.
Anyone else? Okay, thank you.
Okay, thank you for staying for the duration. And I will be around tomorrow too. I'm going to hang out and see the show tomorrow in the evening, so I'll be more casual then. But
I've seen all your stuff very recently. I have no idea where that was.
oh yeah, sure. Thanks. Probably lost the bet.
And I was not traveling so much, so